Section 2.3, stem and leaf diagrams, and we'll do examples 1 and 2. So I started off with an example of what a stem and leaf diagram is. So our raw data is this first row of numbers, 15, 16, 21, 23, 23, 26, 26, 30, 32, 41. So we're organizing them into this new graph that uses numbers rather than like bars and dots. So it's a little funny looking graph. So this is telling us that 32, the way we're going to put 32 on the graph is we put 3 in the stem. We're putting the first digit as the stem. Our stem here is the outside. And then the second digit will be the leaf. And sometimes we'll have more than one digit on the stem. So the stem can be more than one digit. But the leaf is always one digit. And we'll see this as we go through some examples. So you'll see we have the 3 on the outside and then the 2 on the inside. That's 32. Another example, let's look at 15, right? We have the 1 on the outside and the 5 on the inside. So then for 16, the 1 is already on the outside, and we just put the 6 on the inside or the right side. And that's called a stem and leaf plot. We often put a line down the middle just to help differentiate, but overall, that's the graph. So let's make some of these. The first one I started just because we have a lot of data, and it'll make it a little bit easier. So example 1, the following data were obtained for the number of students taking the final for a sample of 40 math classes. So one class had 31 students, another class had 32, another class had 24, and so on. So we're going to organize the data. And it helps to have it in order. You'll see how I have 0, then 4, rather than like 4, 7, 8. So they're just in numerical order, which makes them a little bit easier to read. That's what I mean by ordered. So I did some of the data for you already. So the first row has a 1 on the outside and then numbers on the inside. So this would represent 10 through 19. So I've already done those for you. So the first one is 10. And then we have 2 14s. So we could check 14 and 14. That makes sense. And we could keep checking these, right? We don't need to check all of them. You can trust me, or you could check on your own time, right? There's 2 5s, which means we have 2 15s. We have 3 6s, which means there's 3 16s. And then we have a 7, an 8, and a 9. So that represents 17, 18, and 19. The next row starts with a 2, so that represents 20s, so 20 through 29. Same thing, we could check those, but let's jump into the 30s since I didn't do those for you. So 30 through 39. We're just going to have to search through the table, see what we can find. So I'm just going to highlight all the 30s and then we'll put them in order. So I see a 31, a 32, a 33. If you want to look on your own, you could pause the video. I see another 30, I see another 30. We'll just look around a little bit more and I don't see any more. So then we just write the last digit for each of these for the right side. So 30 would be 0, 30 would be 0. Next would be 31, 32, 33. So 1, 2, 3. Cool. And then the last row would be the 40s. 40 through 49. That's why we have a 4 on the left for 4 10s. And I see a 42. Search if you see any more. I'm not sure if there's any more. So that's all I see. So I'm going to go ahead and just put a 2. And that's the only one in the 4 row. All right, so let's talk about a new question. Write out the class descriptions. So the class descriptions are like what we put in those frequency tables when we said classes. This is like that first column in a frequency table. Like what would we write? So we wouldn't put a 1 because we wouldn't understand if 1 meant the number 1 or the number 10. So instead, our class descriptions are these right here, right? That's what we would put in a table. So 10 through 19 is the description of the first row. 20 through 29 is the description of the second row, and so on, 30 through 39 and 40 through 49. And notice they're all the same size, right? 10 through 19, 20 through 29. We couldn't do like 20 through 25. They should be the same size. All right, so we'll do one more thing with this stem leaf. Sometimes people don't like how long this is. There's a lot of numbers in that middle row. So we split it up to do 2 lines per stem. So basically we're going to split each of these in half. And equally in half. So 10 through 19, if I want to do that equally in half, I would do 10 through 14 and then 15 through 19. Because they need to be the same size. So that's 10, 11, 12, 13, 14, right? That's 5 numbers. 15, 16, 17, 18, 19. That's still 5 numbers. So that's why that's always my cutoff. So then we would do 20 through 24 and 25 through 29 and so on. So it always cuts off at the 5. So we can just use the graph above to figure out what goes in each row. We don't need to use the raw data since we already have the graph. So we're just going to split these up. So the ones would now be 0, 4, 4. And then everything bigger than 4 goes in the next row. So 5 through 9 goes in the next row. And sometimes it's just an easier graph to look at. I did the 2s for you, right? I just split it up. I did anything 0 through 4 goes in the first row. Anything 5 through 9 goes in the second row. And you can see that here and here. I did the 3s, so 0 through 4, 30 through 34 is in the first row, 35 through 39 is in the second row, but this one's empty because there was no data, and that's okay. We're still going to put it because that shows the reader that it's an empty group and shows that 42 is a little bit farther away, but it can be empty, right, as long as it's in the middle. And so our class descriptions are a little bit different now. It's again, what is the description of each row? So rather than 10 through 19, we had split them up. So it'd be 10 through 14, 15 through 19. Instead of 20 through 29, right, we split it up, 20 through 24, 25 through 29. We split up 30 through 39, 30 through 34, 35 through 39. And then 40s, it looks like we only did 40 through 44. We didn't need to include 45 through 49 because there's no data. We don't need to include row empty at the beginning or end. So empty is okay in the middle, but not the end. So we didn't need that one. So just a few notes and we'll do one more example. So the vertical line just helps us separate the stems and the leaves. That's this vertical line. Note 2, the spacing of the numbers needs to be done so it's consistent so that the graph doesn't become misleading. So notice the numbers are all around the same size, the 8, the 9. What would be misleading is if we did 1, 2, 2, 2, and then, I don't know, 3, 3, 2, 3, 3, 3, 3. See how the 3s are much smaller, so they look like they're the same size, but they're not. So just make sure your numbers are about the same size. And then note 3, the leaves can only be 1 digit. I wrote this earlier as well. So the right side is always only 1 digit. But the left side can be more than 1. So the leaf unit does not need to be ones place. So in this example, it was the ones place because 1, 0, that's the ones place, and 1 was the tens place. We can use different units if we need to, and we'll see that in the next example. So the next one, notice we have decimal places, 0.5. So our leaf will be a different decimal place. So example 2, the following data shows distances in miles from homes of students at Chabot. And we're going to create a stem and leaf diagram, and we'll identify any outliers. So in this case, the 0 will be my stem, and the 5 will be my leaf. Again, the leaf is always only 1 digit. So if we had 0.55, this whole thing, the whole left side would be my stem, and only the 5 would be my leaf. And that's okay. But the leaf is always only 1. So rather than writing 0.5 on the graph, we're trying to keep the graph as simple as possible, we're just going to do 0, 5, and we're going to write a little note that the leaf equals the tenths place. So that tells me that it's 0.5. And then 0.7, we just write a 7. So what someone needs to do is they're going to read this little key, and they're going to know that this is 0.5 rather than 5. And so we'll continue through. So 1, so we'll do 1, 1. And that's not 11 because, again, of this note. So when you make one and when you read one, it's really important to think what decimal places do these all represent. So this is not 11. So 1, 2, 1, 2. Again, right, that's not 12. It's 1.2, 1.2. So if you're feeling confident, why don't you pause the video and finish this graph? Otherwise, you can do it with me. Luckily, the numbers are already sorted in order, which will make this go a little bit faster. So 3, 5, 5, 7, 7, 8, 9. So all of these, right, are 1.7, 1.7, 1.8, 1.9. Again, because of this note. So for the 2s, we have 2.0, 2.2, 2.5, 2.6. Notice I'm trying to keep those numbers around the same size as best as I can. 2.8 and 2.8. All right, we'll do the 3s. 3, 5, 3, 8. That's it for the 3s. 4s, 4.4, 4.8, 4.9. 5s, 5.2 and 5.5, 5.7 and 5.8. And then I go to 8. Should we just immediately jump to 8 on the graph? It's tempting, but it's misleading. So we need to make sure the reader knows that 6 and 7 were empty, and then comes 8.0. And that's our graph. All right, we're finishing up. So what are the class descriptions? How do we describe each row, right? The first row, remember, it's not 0 through 9. It's 0.0 through 0.9. Again, that's why it's important to read the little key. So the next row isn't, it's tempting to say 10 through 19 like last time, but again, it's tenths place, so it's 1.0 through 1.9. The third row, what numbers does this describe? Right, it's not 20 through 29, it's 2.0 through 2.9. And we'll keep going. 3.0 to 3.9. Maybe you can do this without me now. 4 to 4.9. And we'll even describe the missing ones, 5 to 5.9. So even though 6 and 7 are empty, they're still there, they're just empty. So 6 to 6.9, 7 to 7.9. And then finally 8 to 8.9. So even though some of these numbers aren't actually on the graph, that's what the row describes. The row describes all these numbers. So it's just the description of the row, not the actual data in the row. And then our final example will be to create a stem leaf using 2 lines per stem. So I'm going to squeeze that in right here. You might have to write a little smaller to squeeze them all in. So remember, we're just going to cut them all in half. So we're going to do 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8. Just squeezed them all in there. All right, and then remember, it goes from 0 to 4 and then 5 to 9. So the first row would be 0.0 to 0.4 and then 0.5 to 0.9. So we only have 0.5 and above, so we actually are going to erase the first row, because remember, we don't want empty at the beginning or end. So the only numbers we have for the first row are 5 and 7 from right here. And then ones we're going to split up just like before, same rule. It'll be 1.0 to 1.4. It's always the cutoff at 5, and then 1.5 to 1.9. So same thing. We'll do anything below 4 and below, and then anything 5 and above. So 1, 2, 2, 3, 5, 5, 7, 7, 8, 9. Let's keep going. So for the 2s, we'll do 0 through 4. So that's only 0 and 2, and then 5 through 9, which happens to be 5, 6, 8, and 8. If you're feeling confident, keep going without me. Otherwise, if you want to work with me, let's go. For the 3s, it looks like we have nothing from 0 to 4, so that one will be empty, and then the 5 and 8 will go in the second version. For the 4s, we have a 4, and then 8, 9. 5s, we have a 2, and then 5, 7, 8 will go in the second half. And then my 0 disappeared, I'll put that back. And then 6, 7, and 8, 6, 7 are all empty. 8 only has 8.0. And then remember the second one would be 8, 5 through 8, 9, which is empty, so we're gonna go ahead and erase that. And that's our stem leaf. So again, sometimes we like to split it up just because we want the data a little bit more spread out. If we were to turn this sideways, you can kind of see like a right skewed shape, and you can see that a little bit better on the second graph than the first graph. So if you just turn your paper sideways, you can kind of see that shape. And that's a stem leaf.